Hello, good day. Today we have a course, Introduction to Computer Networking using the OSI model. So basically, we are going to talk about how computers talk to each other as well as computing devices. Sorry if I may start using these words interchangeably. How networks talk to each other, how traffics are routed, how people communicate on the internet. So that's basically what we're going to talk about today. We are going to use OSI model as a reference for our discussion. My name is Kenechukwu Nicholas Admike. I'm a network engineer in Virtual Informatics. Virtual Informatics is a company of Transform Africa. Thank you and welcome to this session. So first of all, let's talk about networking devices. When we talk about networking here and networking devices, we are looking at different devices, infrastructure that comes to play when ICT is involved with regards to communication. So we are talking about things like let's say, where is my text? Okay, so one, we are talking about things like renters, talking about things like the same category. So let's look at another one. Let's talk about okay. Let's put cables in another category. So let's use printers and let's take cables category. Okay. So we're talking about things like switches, routers. Just to mention but a few, okay? Hubs too, but a few. So there are a lot of things that come into play, okay? But for now, let's stop here. So these are the devices I'm going to be talking about, and every other devices that are involved when it comes to networking. Yes. So when I say computers, for example, all these things can work the same way, okay? But I'll be using computers generally sometimes for these things. So how do these things talk to each other in a network? How do you send an email and it goes to someone in another destination and delivers? How does it work? How does your traffic? How do you make a call? How does these things work? How does this packet move from one point to the other? So that process is what we are going to be talking about today. And in talking about it, we are going to make reference to what we know as OSI reference model. So let me give me a moment. OSI. What is OSI model? OSI model in full means open whichever way that works for you, you're the same. So open system interconnects or interconnection, any of the above. So this is an internationally accepted model in building a network. This is what will guide you in building a network from the scratch to the top, as well as troubleshooting. This model is also important for troubleshooting, because if you understand this model very well, it will be easy for you to have a layered approach in terms of troubleshooting. So what is this OSI model, and how does it apply to the networking we are talking about? So let's see. So OSI layer comprises of let me minimize this, and I minimize this too. Okay, so OSI layer comprises of different layers. Okay, so first we have from top, from 7, there are 7 layers of OSI layer. Application, 6, presentation, transport, you have the physical layer. So I can add layers to each of these. Layers to each of these. Layers to each of these. So these are the 7 major layers of the OSI model. Never forget this. It is very important. You will encounter it almost all the time. You will encounter it. So let's look at it from let's discuss this from a building of a network perspective. Okay, so I'm going to start from the physical layer, although in application, in real essence, when you want to use this layer in everyday use, it comes down from up to down. So I'm going to start from physical in order for us to understand this very well. So I'll bring another tab here. So 1, physical, or I can as well just add it here. The physical layer comprises of your physical devices that you can see, okay, as well as your cables and your connectors. So I rather just add cables. I'll just add this here. So this is the physical layer. So these transmit data in bits, in signals. So at physical layer, you have your cables, you have your connectors. which transmits information in signals. So you will agree with me that for your computer to work, it has to be plugged to power, right? Of course. So that is why the physical layer is very important, because without the physical layer, nothing can work. So there must be connection. It's either you're connected through cable or you're connected through radio. Radio, I mean Wi-Fi or whatever. So those are your physical connection. So it has to be there for any layer for what you're trying to build to work. So secondly, after physical layer, you go to what we call the data link layer. So the data link layer, what do we have here? We have your switches. Have your switches in your data link layer. So you have your switches in your data link layer. So the job of the switch is to make sure information gets to where they are supposed to get to in your network. So that is the job of your switches. So the switch functions internally, what we call intranetwork. So intranetwork is like an office or an organization that is using a particular public IP address. So for you to communicate between one computer to another inside that your network, then your switch comes to play. Your switch makes it possible. So for you to send an email or a file to your colleague in the office, it has to go from your computer to your switch to your colleague. Now, let's have a scenario where your network is new, brand new, built, and your switch. How does your switch identify these computers that are connected to it? And how does your switch know exactly where you are sending information to? So at the layer of the switching, the information there is called the frames. So when you send these signals are packaged, called encapsulation. It's encapsulated kind of into frames. Okay, it's packaged. Okay, so when you send the file or an information from your computer to the switch which is connected. So remember, your computer is connected to a switch through a port. So each computer has a port where it is connected. So when you forward a frame to a switch, initially the switch doesn't know your computer, it doesn't know where the port it belongs to. So what happens is each of these computers or networking devices has what we call a MAC address. It has what we call a MAC address. Every computing device has a MAC address. Don't forget that. Don't forget that. If you look at your phone has a MAC address. So never forget that. So the switch has the power of building what we call the MAC address table. So when you send an information to your switch to send to another computer, okay, which of course you're going to have the address of that computer. So when it gets to the switch will record the inbound traffic. Where is this coming from? Okay, that's the source MAC address. When it gets to the switch will open the frame, the information, and it will see the MAC address, and then it will create something like a table. It will create a table. So in that table, there will be a sort of the MAC address of computer A belonging to ports. That particular port which this information gets to the switch, it will record it. So okay, computer A belongs to port X, for example, and then it will notice. So the switch has ability to switch. It also has ability to learn MAC addresses. So these are the two important use of the switch. So the switch can switch and send information, as well as it can learn MAC addresses. So when you send, it learns your MAC address. So if it knows, if it goes to the MAC, it will now go to the MAC address table where it has stored your information and check for the MAC address of the other computer where you are sending this information to. Remember, in this scenario, we are using a blank switch, a brand new network. Of course, it won't see that computer's MAC address. It doesn't know where it belongs to. So what does the switch do? It records your information and then it floods this information through every other port of the switch. It sends it out, except this particular port which you have used to send. So it knows already that this belongs to computer A, but it doesn't know the port which computer B, where this information is going to, should go to. So it will just spread it through all other ports of the switch. So if the switch has 8 ports, it spreads it through the 8 ports, the information gets pushed out. So when it gets to the other computers connected to this switch, each computer will look at the frame, check, oh, is this my MAC? Is this information, does it belong to me? So it will check the MAC address. If it belongs to it, yes, it will accept the information. But if it checks the data and it doesn't see its MAC address, what does it do? It drops it, because it's not its problem. Okay, so that way you have been able to send your first information. So the computer that has access to it will of course understand the information you have sent. So in that way we have built a MAC address of sending, right, source. But if the switch does not register or learn the MAC address of that computer that accepted it, unless that computer sends acknowledgements or sends information to either this particular computer or another computer. Of course, when it sends, the same process of learning this MAC address, it uses the same process to learn that computer's MAC address as well as the port which it belongs to. So at the end of the day, what you have is a complete visibility of all the connected devices, the printers and the rest that are connected to that switch, their names, their MAC addresses and their port number. So it builds this table. So subsequently, when you send the information, it gets to the switch. You see, the switch will just automatically look at its table, look where it's coming from, the MAC address is going to, and then it will send it to the ports. There's no need flooding it through other ports right now because it has already built its MAC address table. So at that level, the switch will be able to switch information around. So there's already a communication internally in your intra network. So let's go forward. Let's talk about the number 3 layer, known as the network layer. So here we'll talk about the routers. So the routers come to play at the network layer. So what exactly is the job of the routers? What does the routers do here? Also, you have to understand that here we have what we call IP addresses. So here we have IP addresses, the same way we have MAC addresses. Okay. Same way we have MAC addresses, we have IP addresses. So I'll use small letter assignments purposes. Okay. So I'll make this a little bigger so we can see. So at the number 3 layer, known as the network layer, what we have is the routers. So what happens? Now we have been able to establish, give me a moment, I need to signals. Binary bits. Okay, so this is at the physical layer. So just to be for better description. Okay, so back to the network layer. Now we have been able to establish how information is circulated in a network. That's like an office, an organizational network. Now, when you want to send information from one network to the other, you want to move from network A to network B. Remember, all we explained that number 2, which is data link, is the same network at the level of switching. Now, when we get to network layer, this is the level 3, known as the level of routing. Now you want to send information from your network to another. The job of the router now comes in, just like the name implies. Its job is to route traffic from one network to the other. So it does this using different scenarios, different approach, which we are going to discuss in subsequent lectures. But for the purpose of this lecture, we are going to talk about just a shallow introduction to this. So the router sends information based on either the shortest paths or the best paths or the fastest paths. So there are different reasons for choosing which path this router is going to send information. But of course, the path it will choose, of course, will be the best path. Best in the sense that it could be the shortest, or it could be the fastest, or it could be anything. But of course, it will be the best path. So apart from routing, deciding the path which it will send this information through, the next job of the router is to assign IP addresses. Okay, so at that level, IP addresses are assigned. There's what we call DHCP. So DHCP dynamically assigns IP addresses, or you can also add IP addresses statically. Okay, you can add it static IP address, or you can use DHCP to assign IP addresses. So unlike data link layer, where computers are identified based on their MAC addresses, at the level of network layer, networks or computers are known with their IP addresses. We are going to come to that level, how it's these things happen. So when an information passes the switch, gets to the router, going outside the organization, it now routes based on the IP address of where it's going to. So basically, this router has what we call an IP address table, just like the switch has MAC address table. Same way the router has IP address table. So each of the networks where it's going to get to, of course, is going to build an IP address table using their global IP address. So let's move forward to number 4. Number 4 is called the transport layer. So here we talk about transport layer in number 4. So what is the transport layer? Having identified the routers and what it does, sending packets sending information out as packets. Of course, you have identified the paths. The router has identified the paths which it wishes to send these packets out, okay? But there has to be a means to convey this information. There has to be a means. The router wouldn't take it and move. It has to send it through a means. That way, we have what we call the TCP and the UDP. So the TCP and the UDP's job is to make sure that traffic goes from the router to the other end. Okay, TCP in full is transmission control protocol, while UDP is user datagram protocol. So it can either go with TCP or it goes with UDP. Okay, although sometimes they all work hand in hand. But TCP UDP, I'll explain. What is TCP and how does it work? TCP has what we call a handshake. It establishes a connection before it sends information. It's going to say, hey, I have this information to you. Are you willing to receive? The other person or the other computer or the other network at the other end will say, yeah, I'm available. Please send. So it will send. So when it sends, the other network at the other end will confirm, yeah, I got it, thanks. I want to send again. Are you ready? It will send. I got it, thanks. Oh, I didn't get it. Did you send anything? Oh, sorry, I'll resend. So this is what the TCP does. It establishes a connection and talks to the other network that is about sending information. So it takes time, but you will agree with me that it's secure and reliable, because it will make sure that your information gets to where it's going to. In the case of packet drop, it resends. Okay. Then UDP, the user datagram protocol, doesn't care. It doesn't care. It just sends information. It doesn't establish a connection. So it doesn't establish connection. It just sends. It just forwards. It's called connectionless. It's called connectionless. So sometimes I'm thinking of a scenario. Okay, a proper scenario we can use is a phone call. That's a proper scenario we can use, because UDP works mainly for voice. Okay, so in a phone call, sometimes we find out that the call is hanging or it's cracking, the way some people say. So that process is called data drop, packet loss. So when it's dropping, when there is packet loss, you find out that you don't hear some things the other person at the other end is saying, but of course the person is speaking, but you hear the next thing that the person has said. Okay, because UDP does not confirm if the information has gotten to where it's going to before the next information is sent. So it goes fast. So that's why voice call or voice uses UDP, because it's very, very important that voice has to be fast. Okay, so it's fast, but it's not very reliable. In reliable important things, you go with TCP, not your UDP. But UDP is faster than TCP. So that being said, we're going to come back to all these things. We're going to come back and discuss how they work in details. But right now, let's move forward. Let's go to the next layer, known as the session layer. So session layer. Oh, I've already written this. Sorry. This creates a session. So this is what the session layer does. The session layer makes sure that a session is created for the information which you are about to send. So how does it work? The session layer makes sure that connection is established. That is the job of a session. Connection is established and that connection is maintained. It creates sessions. Okay, let me use S here. And maintains. Maintains sessions. Okay. So the job is to create the session, make sure there's a seamless transmission between network A and network B. So that's the job of the session layer. So it maintains the connection. Sometimes you find out that if you're on the web browser for some time, you're trying to go through a website or something, and you pause for a moment and probably attend to something. On coming back, it would have told you that your session has ended or time off. Okay, so these are policies defined at that layer, at that level. I mean, it goes deep into a lot of things, but at the basics, this is what the session layer does. So let's move forward quickly and talk about the presentation layer. Okay, so we are at the presentation layer. So the job of the presentation layer is basically formatting. That is basically the job of the presentation layer. Make sure that the format of the information that is going through is the same as the information that is being received. If you're sending a picture, for example, and the picture is JPG file, you send it, the presentations layer is to make sure that that information you have sent is JPG from beginning to end. So you don't send a video and someone is receiving the video as voice or as a picture. So this is the job of the presentation layer, to maintain formatting. Okay, so let's talk about the final layer, which is the application layer. Okay. Okay. So this is where humans interact with the computer by use, right? By use. This is where you use the computer. This is your web browser as an example. This is your applications. This is your email applications like your Outlook that you want to use to send an email, or your games or whatever. Okay, these applications exist at the application layer. So this is where humans interact with the computer. Okay, so this is basically the OSI model and how it is used in computer networking. So now I said something about starting from 7 top to bottom, right? So in using these in communication, usually you send information from your computer, which is at application layer 7. So this information goes from top to bottom. So it comes down to presentation layer, which formats the information well, okay, appropriately. Then comes to the session layer, which creates and maintains a session. Okay, so the session is responsible for making sure that the information gets to where it's going before at the appropriate time, before ending, and then comes down to the transport layer, which determines which transport method is going to use, either the TCP or the UDP, and then down to the network layer, where the router now picks this information and assigns IP addresses and then routes it through the best path. So that comes down to data link layer, and at the data link layer, the frames, the packets from the network layer are being enveloped by the frames and sent down to the physical layer, which passes through your cables as signals. So this process is what we call encapsulation. Okay, so when it goes to the next computer, of course, it passes through the cable. It passes through cable to the next computer, and then decryption starts, or decapsulation starts the same way it comes from top to bottom. It starts from bottom to top. It starts stripping this information, getting the information you need until you get to the application layer, where you'll be able to view this information. So basically, this is how computers function. This is how computing devices work. Okay, this is how networks are created, and this is how networks interact at that level. So thank you very much for joining this class. I hope you've been able to understand OSI model. You've been able to understand introduction to networking using OSI model as a reference. So it's been an interesting session. I hope you learned a lot of things, and we hope to see you in my next class. Stay tuned to watch my next video. So thank you very much once again. My name is Kenechukwu Admike. I'm just going to put it here. Okay. So so this is my name. Thank you very much for being part of our class today. I hope to see you in the next class. Thank you.